In this video lecture, we're going to interpret the graph of a function. Specifically, our objective, we want to obtain information from the graph of a function, including the values, the domain, the range, and intercepts. We'll pull in a couple other things too as we look to read the graph. Okay, we know a number of things. We had a lot, if I look up here, we had a fair amount of vocabulary in that objective. And so we can go back and make sure that we're familiar with that vocabulary in terms of what we know because we've seen those words before. We of course know what a function is. A function is a relation that associates each element of the domain, each input or each x value, with exactly one element of the range, the output or the y value. We know what the domain is. The domain is the set of all inputs, the set of all x values for a function. Actually, the domain applies to relations in general. It's the set of all x values or inputs for a relation. But we're going to focus on functions, and of course a function is a relation, so I'll just leave it there as function. The range is the set of all outputs or y values for a relation, but again a function is a relation, so we'll focus on a function. And we know what intercepts are. Intercepts are the points at which a graph crosses or touches the coordinate axes. Okay, you're going to want to have a whole piece of paper for this example as we go through, because we're going to draw the graph and then answer a number of questions about it. And as you can see, I'll start at the top here. As you can see, I'm asking a lot of questions, and I want it all together on one page. That way it's easier to refer to the graph as you're looking for it, as you're looking at it. So you'll want to take a moment here. We're just going to do the one example with a graph, and I've made a kind of a basic graph, and I've labeled a bunch of the points on the graph. You may want to press pause, and when you do that, just sketch it out. It goes from -6 on the x-axis to +11, and it goes from -3 on the y-axis to +4, and put all these points in. What I did is I put all the points in first, and then I connected the dots with a line. And don't forget, I've got an open circle here on the end, which indicates that this is the end of the graph, but it does not include the point 11.1. It includes the point 10.999, whatever, but the point 11.1 is not on the graph. So again, you may want to press pause and get that graph. Okay, I'll assume you've done that, and we'll move on to the questions. So I'm going to be shifting my paper up and down a little bit, and that's okay. One thing I want to point out, I want to call your attention to this right here. Okay? Okay, a point, given a function, a point has an x-coordinate and a y-coordinate. Well, the x-coordinate is still an x-coordinate, but in function terminology, the y-coordinate is the f of x coordinate. So x goes in, f of x comes out. Okay, even though it's on the xy plane, in function notation, the output is called f of x. So here we are. Let's look at letter A. Find the function at the when the input is 0. What's the value of the function when the input is 0? And what's the value of the function when the input is -6? Well, when I input 0, that's my x value. I look for x is 0. I'm here. According to the graph, what comes out is going to be +3. So f of 0 is going to be 3. Okay, the value of the function at 0 is 3. This is the x-coordinate. The f of x comes out here is the y-coordinate. And so 0, 3 is right here. How about at -6? Okay, f, the value of the function at -6. I look on the x-axis to find -6. I go down and I see the value is -3. So f of -6 is -3. Okay, letter B. for what values of x, for what inputs, is the output? Is f of x equal to 0? Okay, well this again, this is going to be, you want to put something in and get 0 out, and again, the f of x is the y coordinate, so this is another way of looking for the x-intercepts. This is another way, this is function notation for what are the x-intercepts. Okay, well as I start here, this value of x, -3, gives an output of 0, x, f of x, so -3 is one of them. As I go across here, 6 gives an output of 0, so 6 is another one. And as I continue, 10 gives an output of 0, I have 10. So I have three values of x, -6, which gives -3, which gives an output of 0. If I put -3 in here, 0 comes out. If I put 6 in for x, 0 comes out. If I put 10 in for x, 0 comes out. Okay, I'm going to need to shift my paper, so we'll be up and down a little bit here as we work with this letter C. For what values of x is the function, are the outputs positive, greater than 0? Okay, greater than 0 means we are above the x-axis. For what values of x are we above the x-axis? Well, we're above the x-axis from greater than -3 and less than 6. Okay, we're above the x-axis here, greater than -3 and less than -6. So we can say here, when x is greater than the x is greater than -3 and less than 6. But we're also above the x-axis this portion. So greater than 10, and of course we don't include 11 as an open circle, so less than 11, we're also above the x-axis. We're also greater than 0. So we also have x when it's greater than 10. X is greater than 10 and x is less than 11. If this circle had been filled in here, I would have put a -11 here, but it's not filled in. 11 is not part of the graph. Okay, letter D. What is the domain of f? Okay, the domain is all the x values that are on the graph. Okay, the domain, all the input values that can be graphed, that are applicable, I guess. Okay, let's go to here. Okay, let's notice that in this graph, it doesn't go on forever. The domain is your x values. The domain starts at -6, and it's included. And all the values between -6, all these have y values. Here's 0.1 has a y value. Here is 1, 2, 3, 4.5 has a y value. All the way to 11, but not including 11. Okay, I'm going to write the domain in interval notation. Okay, we have -6 is included. It goes all the way up to 11, but 11 is not included. So a bracket with a -6 to indicate inclusion, a parenthesis with the 11 because 11 is not included. Okay, the next question here, letter E. What is the range of f? Well, the range is the outputs. It's the y values. Let's use our graph. Our y goes from what to what? How much y are we looking at here? Well, the smallest y value is -3. It's right here. Okay? And the largest y value, well, the highest this graph goes is up here, where y is equal to 4. And again, they're both included. We have a closed circle and a closed circle. So our y's go from -3 up to 4, and all of the x's map to a y that's between -3 and +4. Move my paper up here, and we can say that our domain, again, I will do it in interval notation. Okay, our y's go from negative, whoops, I include -3, so I need a bracket. And they go as high as 4, and again a bracket because 4 is included. Okay, so here you have again, the y values go from -3 up to 4. Okay, letter F. What are the x-intercepts? Where does this graph cross the x-axis? Well, it crosses in 3 places. It crosses here. Okay, so one x-intercept is at -3, 0. It crosses the x-axis here at 6, 0. And it crosses the x-axis again here at 10, 0. Notice that F and B have a similarity. For what values of x is f of x equal to 0? As I mentioned earlier, this is another way of asking what are the x-intercepts. So that should come out to be the exact same thing, okay? Or at least the same x value. This is in point notation, the same x's. What is the y-intercept? And as we know, the graph of the function has to obey the vertical line test. And so there's no way you can have more than one y-intercept. You can have more than one x-intercept, but if it's a function, you're going to have at most one y-intercept at most. This one has one, it's right here, and the y-intercept is at the point 0, 3. So again, y-intercept, when it comes to a function, you'll have at most one. Okay, got 2 more questions here. Letter H. How often does the line y equals 1/2 intersect the graph? Well, let's see here. Here's y equals 0. Here's y equals 1. So the line y equals 1/2 is this line right there. This is y equals 1/2. Every point on this line has a y coordinate of 1/2. So this is our line right here between 0 and 1. Y equals 1/2. How many times does our graph intersect? How many times does this line intersect? Well, it hits it here, 1, hits it here, 2, and it hits it here, 3. So it intersects it. Let me scroll up a little bit. Letter H. How often does the line y equals 1/2 intersect? How about 3 times? Okay, last question, letter I. For what values of x does f of x equal -2? So for what inputs, what x values, for what x values do we have a y value, or an f of x, of -2? Let's take a look. Okay, I'm looking for what, so here's -2. It looks like I have 1 here and 1 here that have f of x equal -2. Remember, this is x and this is f of x. Okay, so how about the x value of -5 has an f of x value of -2, and the x value of 8 has an f of x value of -2. So to answer letter I down here, for what values of x does f of x equal -2? For when x equals -5 and 8. Okay, so there you have it. A little bit of kind of reading some of the more basic elements of the graph of a function.